Welcome to this video tutorial on how to complete lab 12110. That stands for front rotated 4 times circle. So looking at this, I see that the CAD cube that we're going to use is not oriented in the same orientation as it was before. In fact, it looks like it's laid down on its side, and this is a crop view of the cylinder that we normally use as a standoff, and that's now pointing to the right. You see that all of the balloons that we need to do are in the top view, and we're not doing any depths here. This is more just for conceptually, how do we rotate a part in Calypso, and how do we align to different datums. Notice that you have datum A is now the top surface, datum B is the circle at the center of the part, datum C is now the right side, instead of being that front edge that we have been using. Looking at some balloons here, I see we have a standard circle, no big deal there. We have an angle that comes off of the x-axis. That's very interesting. So this center mark here is the center mark for a bolt hole circle pattern, and that center mark is implied to be orthogonal or 90 degrees to our primary datum edge. Right, so this looks like it's simple enough. We just have to touch that circle and then output an angle in between this central circle and this outer circle here directly off the x-axis. So it's kind of applying what we learned last week, learning a couple new things. We have a 2" 258 bolt hole circle dimension, so that's new. We're going to have to use the recall function. Oh, look at this. We have a circle down here that is now not held to plus or minus 5 thousandths anymore. That's 591 plus or minus 2 thousandths. So we're going to have to add a couple more touch points or convert this to a scan path. I think in this case, we'll just do some additional touch points, mostly so I can show you how to do that. Then over here, we have a 63-degree angle. That'll be output in much the same process as this 58-degree angle. This will show us how to manipulate some of the angle outputs. A lot of times they come in as negative when they should be positive, or they're coming off the x-axis when they should be coming off the y, or something like that. Same thing with balloon 6 here, just another angle dimension. I do see that with balloon 7, we need to touch this back edge here at some point to be able to output the distance from, I assume, I don't know if that's the center of the bolt hole pattern or the center of the datum. I'm going to assume that it comes from the datum because the datum is more important. But really, that's kind of ambiguous on this print. That's an interesting point. But yeah, we'll assume that balloon number 7 does come off of datum B, which is the center of that circle, not the center of the bolt hole pattern. We have balloon number 8 is 790 thousandths. Okay, so we have plus or minus 10. We just have to be careful on this hole here and this hole here that we get our tolerance output correct. Looking at our title block, 3 place decimals are plus or minus 5, 2 place decimals are plus or minus 10. So that's something to keep in mind. And then lastly, we have this 1" 181. That's going to be output directly off of datum C. Now, looking from the front view here, one thing I will bring your attention to, you can see the cylinder that will be sticking out the right side. And that cylinder is awfully close to the top surface here. Now, it turns out this CAD model is not all that accurate. That cylinder is not even in the right spot on the CAD model. However, we still have to be able to avoid that when we're writing our program for collision detection. So I'll show you a strategy for how to jump up and over this boss when we're making our measurements here. So let's get into it. So we'll start by creating a new measurement plan. And we'll go planner, measurement plan, simulation. We'll dock this over here, and we'll manipulate our XYZ readout so that it's coming off our base alignment. Just so if we look at it in the future, it makes sense. We'll go CAD file, and load. Grab the CAD cube and say open. And this CAD cube is not sitting in the correct orientation. So we'll use the tools that we learned about in the previous video. We'll come over here to modify CAD model. We'll start with positioning. We'll make sure that drag base alignment is checked off. That's so important. We'll check on center. We'll click on position, and then we'll click on this back surface of the model there. And then we'll click here and we'll say apply. All right, so notice that our base alignment is still up here. That's a good thing, but our part has been moved. Now we'll come over to transformation. Now here's where it's really, really click sensitive. You got to be careful what you click on. I'm going to click on the model again and notice that it's now highlighted in that pinkish color. This is so important. We're going to turn on this center button, and that's going to rotate about the center of the model rather than rotating about this base alignment coordinate system, which you can see from a top view is quite far away. So that's really an important point. And then we'll rotate this 90 degrees about the z-axis. We'll hit enter, it gives us a preview, and then we'll hit apply, right? Notice in this window, we also have drag base alignment as an option. And this one, for whatever reason, defaults to off, but you really want to look there. I think, honestly, this should be at the top of both of those dialogues in both the transformation window and in the position window. But hey, don't say I didn't warn you. You always want to look there. If you get some weird results, that's the first place to look, right? So drag base alignment. All right, so we are now in the correct location here. Next thing we're going to do is start touching off to some features. Okay, so we'll hit the, well, actually, I misspoke there. We don't want to touch off to some features. We want to do our base alignment. So we'll again focus on our blueprint here. Notice that datum A is the top surface, datum B is the central circle, and then datum C is going to be this line on the right edge. So let's go touch off to those. We'll open up our base alignment window and say OK. We'll hit the pull down or pull up here and go define select geometry, and we'll click on the top surface. And then we'll hit the pull up and go to define circle on cylinder and click on the cylinder there. And notice that this is populating the appropriate axes for us. Calypso is pretty smart about this. It doesn't always get it right, but in most cases it does. The last thing we need is to define a line on the plane. So we'll click and hold and drag. And now here we can see where we're going to need to modify that clearance data a little bit because it looks like this line is going to want to drive directly through the cylinder. Now again, disclaimer, this CAD model is not that accurate. This cylinder is actually centered on this block. So in the real world, we don't have to worry about this. But for our purposes here, I think it's considered a best practice. So let's look at our order of precedence on our datums. So we have our spatial rotation, that's our orientation, about X and about Y in this case. That's going to the top plane. Our Z origin is also going to the top plane. Our X and Y origin are both coming from circle 1. That's the circle at the center. And then our planar rotation, that's what stops us from rotating about the Z-axis like this. That's coming off the right edge. So you can see datum A is 2 rotations and a translation. Datum B, in this case, is 2 translations, X and Y. And then datum C is a rotation about the Z. So that order of precedence is very important. So we say OK. We see our base alignment update. Looks like our probe thinks it's out in no man's land here. If we want to update it, we just click on the joystick button and then click off of it, and it's updated. Now we'll come into our clearance plane, and we'll say clearance plane from CAD model and OK. It's pretty standard. And now we're ready to start measuring our features. Okay, I make this mistake often. When I have the base plate turned on, a lot of times I click on it trying to pan the screen, and that added an extra line here, so let's go back and delete that line. And let's turn the base plate off at this point. Now our part is positioned. We no longer need that base plate. That will stop us from making that mistake again, or stop me from making the mistake. So we can go back in and edit our strategies here. We can double click on plane 1 and go strategy, and I have mine configured to do 3 points automatically. But let's say you didn't. You're going to come in here and let's see, what are we doing? 3 points there. So we'll go 1, 2, and 3 and say OK and OK. Then we'll come in here to the circle and we'll go strategy. And I have mine configured to do a circle path that has 3 points, and this checkbox is very important. Single points is checked on. If you didn't have that, you could delete whatever points are showing up in there, and you could come over here to circle path and double click on it, and then switch that number to 3 and turn single points on, and there you go. All right, and then lastly, we have this 2D line. So this is going to be new. We're going to learn how to do some clearance data here. Go into strategy. This auto path is going to try to scan or do single points. I'm going to delete it because in this case, I want single points so that I can have a point and a point. And notice that I get 2 separate probing points. I will simply highlight clearance data and copy it. So I did a Control C, or you could right-click copy and then paste it. So if you like keyboard shortcuts, that's Control V, or you could right-click and paste. Right? So we have clearance data, then probe the first point, then clearance data, and probe the second point. So it would have crashed if we didn't do that. Now let's watch what happens. If we come over here and just say run, and let's clear existing results. We'll go with our named alignment here. We'll do our current selection, and the rest is good. And we'll hit start. Okay, so that was a little too fast to see. So I had my simulation speed a little too fast. Let's slow that down. Let's try that again. We'll go into run. All right, much better. So we have our 3 points on the plane. This is painfully slow. The more points you have, that arc motion mode can really be a pain. You can go into feature settings editor and change that. Now, I don't really advocate the use of pause mode here, but in this case it is helpful. I did pause it. I'm slowing the speed all the way down. That way we can focus on what's happening here. Here we can see that the clearance data does indeed bring us up and above to whatever our active clearance plane is and over. And you can imagine what would happen if we didn't do that. So when you put pause mode on, make sure you take it back off and then put your speed back to whatever you want it to be. So that does look good. And now we can start probing off some features. So it definitely looks like at a minimum, we're going to need to touch 1, 2, and 3 circles. And I also believe we need to touch a line on the right side, which we already did. And that's going to allow us to output this 1-inch 181. We also need to touch a line on the back. So right now our probe ended over here at this location. I guess I'll touch 1, 2 points on a line next. And then we'll go actually hole number 1. Then we'll go clockwise, hole number 2, and hole number 3. So does it matter how you do that? Not really, but it might as well be path efficient, so I always aim for that. Notice that right here I am already defining a line on the plane, so I will define a line this way. And then I notice that's added to the feature list. Then I'll hit the pull-up menu and go to Define Circle on Cylinder. The probe will end up over here, so the most path efficient would be Circle 1, Circle 2, and then Circle 3. So now our feature measurement is actually all done. So if we wanted to, we could come in here and hit Run at this point. That will be painfully slow with arc motion mode on. So I'll go over to the Measurement tab, Measurement Plan Editor, and then I'll hit the pull down on travel and go to arc motion mode. Notice that it's on for everything. I'll do a Control A and I'll turn it off for everything. So there are many more adjustments we could make there, but I'll wait till the end. I just want to simulate this quick. From the features list, well, first of all, notice my characteristics list has no characteristics in it. And for that reason, I go into features list and do a Control A, and then I hit run. And I'm clearing existing results, named alignment, current selection, and everything else is good. So we'll hit start here. And there we go. We're touching 1, 2, 3 points on the top, 1, 2, 3 points on that center hole. Notice how much better that runs with arc motion mode off. Touching 2 points on the right side, got a scan path on the other one. I'm going to have to go back and modify that strategy. Notice also how big the retract distance is on these features. That's all stuff we should probably clean up at this point, just while we're thinking of it. You could save it till the end. I mean, 6 of one, half dozen of another, really. But while my mind's on it, I'm first going to correct that strategy for that second line. So I didn't like that auto path, so I'll come into the strategy, I'll get rid of that, and I will convert that over to 1, 2 single points and say OK and OK. And something else I'm going to do, I'm going to go to the measurement plane editor. I might as well do clearance group, and notice that one of these was grouped in as CP, or clearance plane plus Y. I'm going to just grab everything here and make all of them CP plus Z, right? We're only using a down probe, so that's all we need. Clearance distance, let's make sure all of these are set to 0. This is a default in the software, but if your software is not configured properly, and I don't believe I gave you instructions on how to do this particular point, so I apologize for that. This will cause problems when you get on the real machine. For retract distance, the default in my system is 250, so I'm just going to firmly establish our alignment features as 250, and everything else gets my standard value of 50 thousandths. So anywhere between 25 thousandths and 100 thousandths is fine here. As long as you have accurately placed features, you shouldn't crash. I just, for whatever reason, like 50 thousandths. All right, and then arc motion mode, that's off on everything, so we should be pretty good for right now. So if we were to run this again, we would find a lot of that weirdness would go away. But at this point, all of our features are done and have been measured, and this should run just fine in theory. I'll save the time of running the simulation again and just assume that that's good. Now we need to start building some characteristics here. So for characteristics, I might as well go systematically, just like it is on the print. For diameter 472 here, that's going to be a direct output. So that will be circle number 2, it looks like. So we'll double click on that, go to our diameter, and that is 472, and that's going to be plus or minus 5 thousandths. And I just say, okay, so that one was easy. The next one's going to be a little harder. We have the 58 degrees, and keep in mind that comes off of the x-axis. So we did touch off to this axis here, which is the y, but this is dimensioned specifically off the x-axis, and this center mark is implied to come orthogonally off our whatever we used for our planar rotation. In this case, that's datum C. So we need to make sure that we have a 58-degree output when we do this, and it does have to be positive. We're going to need to build a line to do this, so we'll go features, and it's tempting to do 2D line, but the software prefers 3D lines for this for whatever reason. We're going to hit the pull down on our 3D line and say recall, and we are going to go from circle 1 to circle 2. So I click on circle 1, I hold control, and I click on circle 2, and I say OK. And notice that that comes in by default with an A1 of 9.5 and an A2 of minus 30.9 degrees. We're looking for 58 degrees. So I'm thinking that 30.9 degrees is awfully close to this 58 degrees. That's probably a rounding error where the CAD model is not exactly correct. So let's see if we can manipulate this. What if we just rotate that the other way? Nah, that didn't work. So space axis reversal is not working. So what if we hit this button here, reference for projected angle, and we switch that to the x-axis? Well, now we have 164 or 120. Well, let's try reversing that. Aha! So it's a combination of reference for projected angle, that's this icon here, or mirrors geometry and strategy that worked in this case. So we want A1. We can't adjust our nominal at this point. I'm not even going to bother adjusting our tolerance. I just know that it'll be waiting there for us when we go review this over in our characteristics list. So we will be able to modify it at this level. I have some pretty good momentum here, so I'd like to keep that up. All right, so still outputting characteristics. So we have balloon number 3 is that 2-inch, 258 diameter, and that diameter is made up of these 3 holes. Okay, so that tells me we need to do a feature and circle, and then double click on it in the feature list. Hit the pull down and go to recall. Now what we want is not circle 1, but circles 2, 3, and 4. So I click on 2, I hold control, and then I click on 3 and 4 and say OK. And you can see, we'll turn off shading here for a second, you can see that that circle is created in the graphics screen over here. All right, so what are we outputting based on that? It's the 2-inch 258 plus or minus 5, so we can output that at this time. Do we have any positioning elements? We don't. Oh, do we? No, the way I read this print, this 1-inch 181 and this 1-inch 946, those control the position of this top edge and this right edge, respectively, relative to datum B. So we do not have any positional tolerances on this bolt hole circle diameter. Yeah, one could argue that your center mark controls you to the highest default level of precision on your default tolerances here, but it really doesn't specify. You know, to be safe, to be honest with you, we probably should establish a balloon number 3.1 and 3.2, and those would be the X and the Y position. So let's output this X and Y position, and we assume that those are 0 because that center mark is in line with the center hole, and we assume that they're both plus or minus 5 thousandths. Now, I don't know why I'm doing this differently than I did last time, but here I'm updating the tolerances. Ultimately, I have to go back and update these nominals anyway. It looks like the CAD model is also off here, where that y-axis of the bolt hole circle is off 22 thousandths. Okay, it'd be interesting to see what the actual parts are like. So anyway, we output the diameter and x and y, and I'll have to go back at some point and update this blueprint to include 3, 3.1, and 3.2. 3.1 would be the x position of this bolt hole diameter. 3.2 would be the y position of this bolt hole diameter. But to not lose momentum, let's go up to this 591 plus or minus 2. Well, I see plus or minus 2. That's very tight there. So the first thing I'm going to do while I'm thinking of it is I'll find that circle, whichever one that is. And it looks like that's going to be circle 4 here. And I'm going to come into strategy and double click on circle path. And rather than doing 3 points, I'm going to do 7 points. So enter. I don't like how deep that is. That seems like it's relatively deep on the model. You know what I'm going to do as well? I'll say OK here. And I'm going to manually take the Z value of this feature here. And I'm just going to make it a little less deep. I'll change it to minus 250 instead. And notice that updates on the CAD screen here when I do that. All right, so I've modified the strategy, and while I'm here, this is a direct characteristic that is supposed to be 591 plus or minus 2, so don't forget your tolerances here. You can either update them at this point or update them at the end. Looks to me like, at least in this video, for whatever reason, I'm kind of mixing and matching here, so. I do think it's best to always follow a system as closely as you can to minimize mistakes. Perhaps, in hindsight, it would be best to just update the nominals and the tolerances at the end because you're looking at it anyway. And that way, you're always following the same procedure. Perhaps I'll do better on that with the next video, but I digress. Balloon number 5 here. We're looking for this 63 degrees, so we're going to need a 3D line connecting our center circle to our circle number 4 here. So let's go features and 3D line. We'll double click on that. We'll go to recall, and we want to go from circle number 1, hold control, circle number 4, and OK. So notice that our A1 is 27 and our A2 is 9. I don't think that's what we want here. We want this 63 degrees. So again, we'll toggle these buttons here. Reference, well, that's coming off minus Y. Let's try to come off of X and see what we get. So here we have minus 62 degrees. Let's try this space axis button. Well, that flips us way the wrong way. All right, that's not going to work in this case. We'll hit this button again, and we'll go from X to minus X. Okay, so that flipped us the other way. Well, let's try this. One last combination here. Looks like we're still getting minus 62 degrees. Nothing we can do about it, right? Wrong. We actually can. We can come over to recall again, and instead of selecting circle 1 first and holding control and selecting circle 4, we'll select circle 4 and then hold control and select circle 1. It's so subtle, but it makes all the difference. That toggled some of these things, so we'll have to play around with this. Aha! So it's a combination of the order that you select the recall in. I know that is persnickety, but hey, that's Calypso for you. It's also a combination of this button here, reference for projected whatever, and this one mirrors geometry and strategies. And that's particularly helpful for 3D lines that are constructed with recall. All right, so we'll turn this on. We cannot update it at this time. I'm not even going to bother doing the tolerances. Maybe I'm taking my own advice from 35 seconds ago. All right, man, this is getting exhausting. We got another 58-degree angle from the center hole to the upper right hole, whichever that one is. So we'll go again to features and 3D line. And I think this one's going to work out if we recall from circle number 1 to circle number 3 and say OK. And nope, it would be nice if it worked like that, but it didn't in this case. We will have to manipulate our reference for a projected angle. And instead of coming from Y, we'll come from X. And hey, that one came in pretty clean. Our A1 is going to allow us to output a direct characteristic here. And we're off. All right, balloon number 7 is this 1-inch 946. Well, that's easy. That is simply the position of this line. And that can be output as a direct characteristic. So let's go find that line. That's going to be line number 2. As you can see from the graphics screen, it is back here. So we'll just double click on that. We'll output our Y, and I'm not going to bother with nominals and tolerances because, like I said, we'll end up having to edit that in a few minutes anyway, because some of those 3D line features don't let us edit it. All right, this diameter 790 here, that is a, tricky one. That is a 2-place decimal, so you got plus or minus 10 there. So we'll just watch out for that. That is going to be circle number 3. So we'll output the diameter. That is, I'm just going to say OK for now. We'll update those tolerances after. And then lastly, we have balloon number 9. And balloon number 9 is going to be the X position of this right surface here relative to the central datum. So that would be 2D line number 1. We'll double click on that. We'll output the X and say OK. All right, so I think that's it for this video. Other than that, we just have to come to our, characteristics list. We have to run down top to bottom. We have to double click on them. We have to rename them so that they follow the standard operating procedure of balloon number and then an underscore, and then whatever the feature is, and then an underscore and some identifier. We have to update the nominals and the tolerances for each, and then we have to run it all the way through and get our dimension report. But I'm not going to extend the length of this video any longer on behalf of that. I think you've seen what you need to see. Happy programming, and I'll see you at the next video.